Hello everyone, welcome to a new video tutorial on graphing of quadratic functions. For us to start, let us begin with our most essential learning competency, which is to graph a quadratic function by the following vertex of the intercepts and direction of the axis of image. Objective like concepts of the graphs of a quadratic function. Number 2, construct the function and label its parts. And number 3, describe the behavior of the graphs of a quadratic function. So let's start with defining the key concepts. So we have 5 key concepts. First, the vertex form. The vertex form is equals 8 times squared plus k, wherein on the vertex form we define into vertex, which is the ordered pair hk. So the vertex is the point of the parabola where the graph is. So if this will be the vertex, if it's going downward, or after the point, it will go upward. So that is the vertex. And then the vertex point can be a maximum minimum point depending on its opening, the value of a. If it goes downward and the value of a is less than 0 or a negative number, therefore the vertex is a maximum point. If it opens upward and then the value of a is positive number or greater than 0, therefore the vertex is a minimum point. Third key concept, we have the axis of symmetry. The axis of symmetry is the line that divides the graph into half. So as you can see on our illustration on the lower right of your screen, we have here our axis of symmetry represented by a broken line with 2 arrowheads. So the equation for the axis of symmetry is given as x equals h, wherein h will be our x coordinate in our vertex. After the axis of symmetry, we have the domain. For the domain, this is the set of all real numbers. It is usually represented in symbols as x, such that x is an element of real numbers. For the range, it depends upon the opening of the graph. If the graph opens upward, therefore this will be y, such that y is greater than or equal to k, wherein the value of k will be the y coordinate from the vertex. If it opens downward, therefore y such that y is less than or equal to k. So those are our key concepts for graphing quadratic functions. Let us now proceed with achieving our MELC. For example number 1, we have here y equals the quantity of x plus 2 quantity squared plus 3. So this given is already in its standard form, so we can easily identify what is the vertex or the values of h and k. For the vertex, this will be negative 2 and then positive 3. For the value of h, we usually get the opposite of the number inside the parentheses. If it is positive 2, it will become negative 2. Vice versa, if it is negative 2, it will become positive 2. And then for the value of k, we write it as it is. If it is a positive number, just like this one, positive 3, therefore the value of k is also positive 3. This is true because our equation for the vertex form is y equals a times the quantity of x minus h quantity squared plus 3. So the negative h inside the parentheses denotes that the value of h should be the opposite. Let us now move on with our table of values. So for the table of values, I already constructed a table for x and y, wherein I have here 5 boxes on the right side of x and 5 boxes also on the right side of y. I have highlighted this portion because I am going to write the vertex here on the highlighted part. So let us write negative 2 as the value of x or h, and then 3 as the value of y or k. For the x values, we assign. And then for the y values, we solve. In assigning the values for x, we locate negative 2 on a number line. So let us use the Cartesian plane on the left side. So if this is negative 2, pick two numbers on the left side of negative 2 and write it down on your box. So the two numbers on the left side are negative 3 and negative 4, respectively. Negative 3 and negative 4. After that, we pick two numbers on the right side of negative 2, which are negative 1, and don't forget the origin, which is 0. So we will have negative 1 and then 0. For us to find the values of y below, we solve for it. So solving y in terms of x, we use our original given, which is y equals the quantity of x plus 2, quantity squared plus 3. And then we let x be the values. For the first value, let x be negative 4. Simplifying or substituting the values, we will get y equals the quantity of negative 4 plus 2, quantity squared plus 3. So we just substituted the values. After that, we simplify. Negative 4 plus 2, it's negative 2, quantity squared plus 3. Simplify further. Negative 2 squared is 4 plus 3. 4 plus 3, it's positive 7. Therefore, the number below negative 4 is 7. For the value of y when x equals negative 3, let us solve. Y equals the quantity of negative 3 plus 2, quantity squared plus 3. So this will be negative 3 plus 2, that's negative 1, and then quantity squared plus 3. Negative 1 squared, it's positive 1 plus 3. This is just basic addition. 1 plus 3 is 4. Therefore, the value of y when x equals negative 3 is 4. For us to not substitute values for negative 1 and 0 anymore and avoid lengthy solutions, we can establish a pattern. So, if this is 4, therefore, this is also 4. Since on the graph, they are on the same x-axis. And then, if this is 7, this is also 7. So this is just a technique or shortcut for us to not or avoid lengthy solutions on solving negative 1 and 0 and substituting and then lengthy solutions. So for us to find that, so we can simply get its the number beside or opposite them. So yung tinatawag natin na katapat. Or you can also solve for this through checking and then substituting x with negative 1 and 0. So you will arrive also on the same answer. So after solving for the table of values, we are now ready to plot the points and graph the quadratic function. So let us first write again the vertex, which is negative 2, 3. Let us plot the points, starting with negative 4, 7. Negative 4 on the x-axis and then positive 7 on the y-axis. So this will be our point. When plotting the points, do not forget to label its parts or label the point, which is negative 4, 7. After negative 4, 7, we also have negative 3, 4. So this is negative 3 and then positive 4. And then don't forget to label negative 3, 4. Next point, we have negative 2, 3, which is the vertex. So negative 2 and then 3. As you can see, part by part, we are now making the parabola or the U shape. So let us label this as negative 2, 3. Next, we have negative 1, 4. So negative 1 and then positive 4. So this is what I'm talking about. So they are on the same axis. That's why they both have 4 as their y-intercept or y value. So negative 1, 4. And then for the last, we have 0 and then 7. So as you can see, even though we are not connecting them, so we can still see that it is a parabola or U shape. So we are done with plotting all these points. Let us now connect the points for us to have the parabola. Let us try to make a U-shaped pattern. And then don't forget the arrowheads. So you can improve your drawings better than this one. So let us now establish all the values in our table on the right. So as you can see, based on our graph, which we labeled as y equals the quantity of x plus 2 quantity squared plus 3, the opening of this graph is upward. So if this is upward, therefore the vertex is the therefore it is a minimum point. For the axis of symmetry, so we establish that as x equals, and then the value of h here is negative 2, so we simply copy negative 2. That's why x equals negative 2 is the equation of the axis of symmetry. Let us draw the axis of symmetry in our graph. So just draw a line or broken line passing through the vertex. As you can see, it will pass through negative 2. That's why the axis of or the equation of the axis of symmetry is x equals negative 2. So we can also label this as x equals negative 2. Now for the domain. For the domain of this function, the automatic answer is x such that x is an element of real numbers. Since we can extend this parabola and all the values of x are possible, so the domain is a set of all real numbers. So for the range, we pick which is the most appropriate. Since it opens upward, we choose this one. So we will have y such that y is greater than or equal, and then for the value of k, we pick that in our vertex, which is 3. So that is how you make a graph for quadratic functions. So let's try another example. Let's have f of x equals negative 2 times the quantity of x minus 1 quantity squared plus 3. So this is also in its vertex form. So it is easy for us to determine what is the value of the vertex. In case that the equation or the given function is in its general form, kindly transform it first into its vertex form for you to be able to identify the values of h and k. Again, for the value of h, so the opposite of negative 1, it's positive 1. And then for the value of k, as it is, so that will be 3. So the vertex is at 1, 3. Now for the assigning of values, on the left side of 1, we have 0 and negative 1. And then on the right side of 1, we have 2 and 3. For you to check, you can check if it is in a logical pattern. So negative 1, 0, 1, 2, 3. So it's correct. So for the values of y, we solve again. So let us solve for f of x equals negative 2 times the quantity of x minus 1 quantity squared plus 3. Substitute. If x equals negative 1, we will have f of x equals negative 2 times negative 1 minus 1 quantity squared plus 3. This will be negative 2, and then simplify first the numbers inside the parentheses with its exponent. So negative 1 minus 1, that's negative 2, and then quantity squared plus 3. Simplify further, negative 2 times negative 2 or negative 2 squared, that's positive 4, and then kindly copy plus 3. Negative 2 times 4, it's negative 8 plus 3, we will have negative 5. So we write negative 5 if the value of x equals negative 1. Next value, if x equals 0, so let us have the same format or the same equation. F of x equals negative 2 times 0 minus 1 quantity squared plus 3. So this will be negative 2, and then 0 minus 1, it's negative 1 quantity squared plus 3. Simplifying negative 1 squared, it's positive 1. So negative 2 times positive 1 plus 3. Negative 2 times 1, it's negative 2 plus 3. The answer will be positive 1. Now we have the values, we just write the corresponding value to the number on its side or on the number matching them. So this is 1 and the other one is also negative 5. So that is the shortcut. So now let us plot the points. So again, the vertex is at 1, 3. Plotting the points, let's begin with -1, -5. So -1 and -5, so it's located on the third quadrant. And then put a label -1 and -5. Or -1, -5. Next is 0, 1. So we have 0 and then +1. So write a label again, 0, 1. Next, 1, 3. 1 and then 3. So this is 1, 3. Next, we have 2, 1. After that, we also have 3 and -5. So don't forget the labels, 2, 1 and then 3, -5. Okay. So as you can see, it is a U pattern even though we're still not making or connecting. So let's connect. So we try to make a nicer version of U because it's so narrow. And then an arrowhead, and then let's try on this side. Okay. So this is our parabola, and then let us label this as f of x equals -2 times the quantity of x minus 1 quantity squared plus 3. Now we identify the opening of the graph. So for the opening of the graph, obviously it opens downward. For the vertex, since it opens downward, it is the maximum point. For the equation of the axis of symmetry, we just write x equals and then the value of h is 1, so x equals 1. And then we can still draw on our graph. So let us have the broken lines passing through +1. That's why the axis of symmetry or the equation of its axis of symmetry is x equals 1. So you may choose to extend your line. So this is x equals 1. And then for the domain, the automatic answer again, so we will have x such that x is an element of real numbers. And then for the range, we choose downward. So this will be y such that y is less than or equal, ang value ng k natin is 3. So now we have already graphed or construct a graph for this quadratic function, and we have identified the certain parts which are the vertex. So the intercepts are on the table of values, which are x-intercepts and y-intercepts. And then for the opening of the graph, is it upward or downward for the vertex, which is a maximum or minimum. For the equation of the axis of symmetry, which is x equals h. For the domain, which is the automatic answer, the set of all real numbers. And then for the range, we have here y such that y is greater than or equal or less than or equal to k. So that ends our discussion. Thank you for listening. God bless everyone. Keep safe.